So in this problem, we need to transform the given polar equation r equals to 2a cosine theta into its Cartesian equivalent. Let us begin. Now let's say we have a point P whose Cartesian coordinate is given by x, y. Then in that case, we can represent each of the coordinate, the x and the y coordinate, in terms of r and theta as r times cosine theta, and y can be expressed as r times sine theta. We will be using this two relation to convert our given polar equation into its Cartesian equation. So let's begin. Here we have the equation r equals to 2 times a cosine theta. Let's do one thing. Let's multiply both sides with r. So we get r squared equals to 2 times a multiplied to r cosine theta. The reason why we multiply both sides with r, because now we have r cosine theta, which we can replace easily with x. We get r squared equals to 2 times a x. So the right hand side is fine. We now have converted the right hand side to its Cartesian equivalent. Now next goal will be to convert r squared to its Cartesian equivalent. So here we have x equals to r cosine theta and y equals to r sine theta. Let's do one thing. Let's square x and add it to the square of y. So that means we now have r squared multiplied to cosine squared theta plus sine squared theta. Luckily, cosine squared theta plus sine squared theta, that's a standard identity with a value equals to 1, meaning x squared plus y squared will now be equivalent to r squared. So what we can do, for the expression r squared on the left hand side, we can replace with x squared. So we get x squared plus y squared equals to 2ax, and this is going to be the equivalent Cartesian equation of our original polar equation r equals to 2a cosine theta.